W-A-S-P, water, air, animals, soil, plants. These are all of our cyclable things. The non-renewables are really different. The non-renewables are FF, Con, M, and M. Oops, a little bit bigger box. FF, Con, M, and M. All of the non-renewables come from underground. We have to mine them out, dig them out, pump them out, but they're all deep under the ground. They don't go in cycles, and even though the Earth is making more, it takes longer than a lifetime before we have more ready. Longer than a lifetime. So the FF is fossil fuels, and the fossil fuels are coal, oil, natural gas, and then it also includes, a little separate from the fossil fuels, but they're also underground, non-renewable, minerals and metals. And then last but not least, we have alternative. And alternative is talking more about alternative energy sources, new ways of finding energy, alternative energy sources. And these are great because these never run out. We can use them over and over, every day, every day, every day, every day. And that includes, of course, solar energy from the sun, wind, ocean tides, and then a few new ones: biofuels, geothermal, and hydroelectric. And we're going to learn more about those later. But there are three main categories for sorting out our resources, classifying resources. Renewable resources going in cycles, non-renewable dug up from under the ground longer than a lifetime to make, and alternative energy resources, new ways of finding energy that's not going to run out on us. Organisms interacting with the ecosystem. There's a few different ways organisms can interact. Remember, organisms means both animals and plants. So we need to look at both kind. They interact with the ecosystem. The ecosystem is just the area in which they live. Their environment is the system of the non-living and the living working together. Let's look at an animal first. We have the bird, and the bird can interact with its ecosystem by coming into a new area, and it can build a nest. It goes in and it makes a change in the area, on the tree. We might could draw two different pictures. Maybe we have the tree with the branch before, and then we can have a tree with the branch after. Same tree, but now we have the bird nest. And here's the nest that the bird has made right here, sitting on the limb of the tree. The tree doesn't build the nest itself, only the bird. So the bird is interacting with the living and the non-living. The living would be the tree. The non-living would be all the little twigs and branches, the dead things for the nest. Twigs, leaves, whatever it wants to use. I don't care. It can use whatever it wants. But that's how the bird is interacting. And we came up with a long list of other animals that interact with their environments, ecosystem, like the beaver. He builds his home on the river, and when he builds his home on the river, it blocks up the river, making changes, just a noticeable change that you can see. Maybe a bee making honey, building a hive. The hive is not there before, but now it is. The bee has gone in and it has interacted with the ecosystem to create what it needs. Well, that's animals. What about a plant? Well, let's go back to the tree. For several months of the year, the tree is nice and green. It has all these lovely leaves on it. The tree is getting everything it needs, plenty of water, nutrients, plenty of sunlight from the sun. Maybe we'll call this summer. But as we start heading into fall and winter, things change. The daylight hours are not quite as many. And the trees go through changes, and instead of being covered with leaves, now they're covered more with just their branches. I guess the branches were there the whole time. But because there's less daylight, the leaves have all changed. They've changed color, and the leaves are now all piling up on the ground. And we'll even have some blue leaves and some red leaves. The color of the leaves is not important, but you can see, has the tree interacted with its environment? Yes, it's done what it's supposed to do. When it has plenty of sunlight and plenty of everything it needs during the summer, it grows beautiful leaves. But during the fall, the leaves fall off the tree, covers our ground, it makes a noticeable change. The tree has interacted with the ecosystem. Magnetism. Well, we got out our magnets and we saw several different things with the magnets. Perhaps the most important thing we saw about magnets do have a north end and a south end. And we found out real easily that if you put the two souths together, the souths will repel. You will feel them pushing against each other, away from each other. They do not want to come near each other. In fact, some of the bar magnets even turned around and aligned themselves so that the north end was close to the south end. The north end wanted to attract and pull towards the south end. So we learned real quickly that the opposites attract with the bar magnets. Opposites attract, and then the same poles repel or push away. Then we did testing with the magnets to find out what types of materials were attracted to the magnets. And it was an easy little list to make. Attracted, non-attracted, and we found out that some metals are attracted, but we also have some metals that are not attracted. So we couldn't just say metals are attractive or metals are not attractive. We had to break it down which metals are attractive, and we found that iron is attracted, nickel, and cobalt. I don't think you have to know the actual names of the metals. I think you just need to know that some metals are attracted. And then some metals are not attracted. I think you do need to know these. Aluminum foil is not attracted to the magnet. And then we also found that the copper penny was not attractive. So again, some metals are not attractive, while some metals are. Reflection is a pretty easy topic also. Reflection, it comes from light. Light always travels in a straight line. That's why you can aim that flashlight, wherever you're at, and if you're aiming at this direction, the light will continue in that way until it hits an object. If you aim the flashlight this direction, then the light goes exactly where you want it to. You never have to wonder where the light from the flashlight's going to go. It travels in a straight line in the direction that you aim at. We tested many different items for reflecting of light also, and we found out many different types of items reflect, while some do not reflect, such as the shiny spoon, the surface of the water that's nice and calm, a lot of shiny metals, mirrors, and the list keeps going and going and going. Things that did not reflect were usually dull, sometimes they were dark, or they were not smooth. So I think overall we kind of came to the conclusion that most things that reflect happen to be shiny. It doesn't have to be a mirror. It just needs to be shiny. Next came weather maps. Maybe the first part you need to know about weather maps is that there's 3 different kinds of fronts that come through. We have cold fronts, we have warm fronts, and then we have stationary fronts. And that's how they look like on the map key. It's important to read your map key to see what's going on. I'm going to draw a really terrible picture of the United States. There it is. And the main thing we've noticed about cold fronts is as cold fronts come across the top of the nation, this might end up being on Saturday. Saturday it may be in the north of the nation, but a day or two later we might find it more down in central of the United States, Saturday, Sunday, so maybe this was on Monday. And then later that same week, maybe by Wednesday, Thursday, towards the end of the week, it's pushing on through the southeast. Wednesday, Thursday. But the main thing we notice is there is a pattern. Most cold fronts tend to start in the northern area of the United States, and over the course of several days every week, they slowly travel throughout the United States, ending up somewhere down here southeast of the United States. So we can make predictions based on the weather fronts that we see. It is important to know that cold fronts do travel the direction that the triangles face. So when looking on a map, if you see a cold front, it is headed the direction of its arrows, while the warm front heads in the direction of its bubbles. So warm fronts tend to go towards the north. Stationary fronts stay. They don't move much. They hang out several days, sometimes up to a week. They just stay in that one spot. They can't travel anywhere. So they just hang out. Food chains. The primary source of food chains, it all goes back to the sun. Without the sun, we can't even have a food chain. Mr. Sun is way up there in the solar system and outer space, sending down these wonderful, wonderful rays of energy. And that's what the food chain is all about. It's all about energy. And the energy from the food chain starts with the sun. From the sun, it goes down to the producers, or our plants. Plants are able to produce their own food. They don't have to go to the store. They don't have to go and buy something or make something. It just happens. They take the sun's energy, it comes into the plant, and with a few other ingredients, they're able to grow strong and healthy and fill their leaves, fill their stalks, whatever we're eating, the corn, the apples, or whatever, full of stored energy. So the producers take the energy, they produce or make food. Now, the main characters who are interested in this food come along next, and the energy travels to the primary consumer. Consumers do not make their food, they have to get their food. The consumer gets its food. The consumer getting its food from the plants is going to be called a herbivore. And they get their energy from eating the plant. Let me draw a really bad picture of a herbivore. Here's the herbivore eating the grass, bushy tail, taking in the energy, and nice and happy. But that's not where the energy stops. After the herbivore, there's another consumer that can come by, and he too gets some energy. We'll just put him over here. This would be the secondary consumer. And he's not a herbivore. Herbivores eat the plants, so the secondary consumer, he is a carnivore, eating on the meat. But he's got the same idea in mind. He just wants the energy. And we'll draw some nice big teeth. Carnivores usually have nice big teeth. We put that into an eyeball. Oh, there's the head of the carnivore looking for some food. And he's going to find it in the herbivore. But the whole reason he gets the food is to get